Hello, hackers. Welcome. Today we have reflected cross-site scripting attack. A very interesting topic, very used still in the bug bounty platforms. And I want to show the way in how you can exploit this vulnerability in a control environment. And we are going to test this against the DVWA, which is the damn vulnerable web application. But before to start, if you want to follow along, I suggest that you need to test this in your Kali Linux. So you need to have a Kali Linux installed, either standalone machine, or if your choice is different other Linux flavor or Windows OS or Mac OS, you can install any virtualization client and install Kali Linux in there. Of course, on top of the Kali Linux, I'm using the Websploit Labs. This is by Omar Santos. He created this lab, which you can install it with one single code liner in here. Once you run this in your Kali Linux machine or Parrot OS, for example, you'll have all these bunch of machines in here available for you to test and analyze and play around. It's an control environment, so it's safe. So in this case, here we'll try to use the DVWA for this lab. So again, the Websploit is a very good lab that you can install. It's a man-in-the-middle framework that can be used for network scanning, vulnerability assessment, and exploitation. It's widely used by penetration testers and security researchers to test network security and exploit vulnerabilities. For this video, so like I mentioned, we'll use the DVWA to perform our cross-site scripting attacks. Right. Okay, so what is the reflected cross-site scripting attack? It involves a malicious script being reflected off a web server to the user's browser, typically triggered by a link that the victim clicks. So this request targets a vulnerability that allows the execution of the malicious script. So in this case, we have the DVWA, which is a PHP MySQL web application intentionally designed to be vulnerable to common attacks. It provides a platform for security professionals to test their skills and tools, and also for students and educators to learn about web application security in a legal environment. Um, yeah, so the DVWA offers 4 security levels: low, medium, high, and impossible. Each level requires different skills to exploit. So this level represents various security measures that developers might implement in their application. So in this lab, we'll exploit vulnerabilities at low, medium, and high security levels. All right. So the first step what we need to do is to connect to our DVWA web application. Here you'll be prompted with username and password. So remember, you need to go to this exact IP after you install the Websploit framework in your local Kali machine. You go to this specific IP 10.6.6.13, and the username is admin and the password is password. And voila, we are inside now. So like I mentioned, the web application has 4 security levels, which are in description here: low, medium, high, and impossible. So in our case, we'll start with the low level security, and we'll see what will happen when we try to exploit the reflected cross-site scripting. So from the drop down in here, first time you log into this web application, your security level will be impossible. So you, on the drop down, you choose low, you submit, and done. So now we go into our tab in where is XSS reflected, and in what's your name field, we can add any text we like, and we'll see if the web application is vulnerable to whatever we input in that field. So we can put reflected test, for example, and we submit. Okay, so we can observe that the message hello reflected test does show up. So at the low security level, the application does not sanitize user inputs, meaning that any data entered by a user is directly reflected back in the response. This makes it easy to inject scripts into the web page, which is a common vulnerability in poorly secured applications. So in this case, if we try to view the source page of our web application, so in this case, I'm going to press Ctrl U in my keyboard, and if I'm scrolling down, there is no many line of codes in here, so it's only around 100. So it's very easy to spot uh, the message that we were presented earlier. We have here hello reflected tests. So this indicates that the user input is inserted into the page's source code, suggesting a potential vulnerability to reflect the cross-site scripting attacks. So you can see it's embedded in the HTML source in here. So now if we try to close our source code page and we go back to our what's your name field, we can try to input a payload to see what is happening. Okay, if we'll get a response back as well. So in this case, our payload, so we need to write a script, short script, sorry, alert. So we can put here you are hacked, for example. All right, and we close our script payload statement here, and we submit. Now we'll see what will happen when we click on submit. Okay, voila, so we have a pop-up in here. So the web application has failed to sanitize user inputs, allowing an attacker to inject and execute a script within the user browser. So in this case, we have just a simple payload with an alert in there just to pop up in there. But in this case, at this level, we can inject any type of script, malicious script, for example, if we want. Yeah. So this is a significant vulnerability because it can lead to session hijacking, defacement, or even redirection to malicious sites. Okay, so for example, now if I'm copying the infected URL in this case, yeah, and I open a new tab, let me close this one, yeah, and I open a new tab in here and I'm pasting my URL. Okay, what will happen is that the same alert box should appear, like here, indicating the execution of the malicious script when that URL is accessed. So in an ethical hacking scenario, for example, if you work for any company or even if you do bug bounty, you would insert simple test script like we did in here into input fields to check for execution, indicating vulnerability. Such vulnerabilities could be exploited even in phishing attacks. In this case, having such a low-level security implementation in this web application right now will be very unlikely that you'll find any websites right now with such a low-level security configuration. Right, normally right now all the web applications, they come in by default with quite high standard security configuration into it. Great. So now the next step we can do is to try to increase our security level in here from low to medium, and we'll see how our web application will behave in this case. Okay, so we submit and we go back to our reflected cross-site scripting tab, and we'll try to see if in this case um, uh, the same payload that we use in the lower security level configuration, if it's working in the medium one. So we're gonna add the same one. So we're gonna put script alert. Here we can add the same. You are hacked. All right. So now we submit. So what we found out that this time no pop-up appears indicating the script did not execute. So the script is shown as literal text in this case here, right? So at the medium security level, the application includes some basic input sanitization, like in this case. However, these measures these measures are often incomplete and can be bypassed with slightly modified payloads. So if we click right now in View Source button to examine the PHP code, of course, in a real scenario, you will not be able to access the backend source code to see how the web application is configured. But in this case, for this lab purposes, we are able. So the web application UI does facilitate you to view the source, the backend, so you can understand better what's going on and how it's configured. Okay, so if we check this line of code in here, so the filter removed the script tag, rendering the payload ineffective. So to bypass this filter, we can use a different casing, such as, for example, capital S C capital R I P T. Okay, so let's do it together. So for example, so in this case, I can see that because in here we can see that it's not allowed in lower cases, right, to input any payload, right? But if we try to change the casing on our payload, we'll see what will happen. Okay, so if I'm going back and I'm adding my payload again, SCR capital RIPT. If you can't follow along this time in the video, you can access a link below that I'll provide to you, which is linked to my blog, Hacker News blog called Wirepost, which I'm maintaining, so for the same purposes, so you can go there and go step by step and follow the lab. Okay, so I'm just gonna write my payload in here again. You are hacked. So now I'm just gonna close my script with the same values, the same characters. Okay, so what will happen now when I'm gonna when I'm going to click on submit, that now the pop-up alert appears again, indicating that the filter is case sensitive and can be bypassed with different casing. Okay, so now what will happen if we increase our security level to high, for example? All right, so from medium going to high, we submit, and we're going back to our XSS reflected tab. All right. So now we try to, for example, to use the same script that we use, the same payload that we use in the medium security level, we try to use in the high security level. Okay, so in here, we'll try to add again in our what's your name field. So add our script again. All right. You are hacked. All right, so let's see what is happening now. All right, so we just observed a hello message and no alert pop-up. So if we analyze the backend again for more insights, we can see that, yeah, we can see that the high security level, more sophisticated input validation and sanitization techniques are employed. Yeah, like this regex in here that we can find in this line of code. Yeah, so the regular expression are used to filter out any attempts to inject scripts. Okay, but in this case, for example, to bypass this filter, we can use an alternative HTML tag. All right, so let's try an alternative HTML tag, for example, the image, right? So we can add an image here. We can put a source of the image, which is X, I don't know, on error. On error, we can try to add to see an alert. So because the source in this case, because the source will be invalid, on error, we're going to try to trigger an alert from the backend of the web application. Okay, so alert. Again, we can put you are hacked. And again, we can close our image in here. So let's see what will happen in this case. Okay. Did it work? Didn't work. Let's try again. So we have an image here. If we can do that. Let's try again. Image source equal X on error alert. Let's try that. You are hacked. Let's put it with underscores and we'll see if it's working. Okay. So now let's submit. All right. So the cross-site scripting pop-up box will appear again, confirming the successful bypass of the filter and exploitation of the vulnerability at high security level. So yeah, that's it for the reflected cross-site scripting on this 3-level security configuration setup. I hope you find it useful, and if you like it, please subscribe for more videos, and if you have any questions, you can put it in the comments below. Also, I left a disclaimer for this video in the description because this video is intended solely for educational purposes. So the goal is to highlight web security vulnerabilities and help developers and security professionals understand how to safeguard their applications. So all demonstrations of vulnerabilities or exploits in here are conducted in a controlled and ethical manner. Okay, have a good day, hackers, and take care and stay safe.